Now, on the last video, we wound up with no solution. Sometimes that's frustrating to students. They're like, I did all this work and there's no solution. But you just have to be happy knowing you got it right. Now, the fact that it had a trinomial in the denominator, that doesn't mean it's going to have, no solution. That's just how I labeled it. But, every equation they give us, well, we might have no solution. We might have a solution. We might have more than one solution. We don't know. That's the fun and the excitement. We don't know how it's going to turn out. But the steps are the same. Okay? So, in this first one, in this example number 5, we're going to look at the denominators. Now recognize that this is a 5 over 1 if you like. That's why I labeled this that it's a rational equation with a whole number, because sometimes students get thrown by the whole number. Okay, the x plus 4, that's fine. But x squared minus 16, that factors. That's the difference of squares. Now you want to make sure you factor those, otherwise you won't be getting the LCD. Okay, so, and you wouldn't get the extraneous solutions. Okay, so x cannot be -4 or 4. So just note to self, when we're all done, we got to make sure the answers aren't -4 or 4. Okay? All right, the LCD. The LCD this time is going to be x plus 4, x minus 4. Now, if you're worried about the 5, don't worry about the 5. It's in the numerator. It's not in the denominator. Okay, so I'm going to recopy the problem to give myself a little room. And you'll notice sometimes they have 2 rational expressions on the left. Sometimes they have 2 on the right. That's just the way they chose to write it. I can put the 5 over 1. I don't know if you want me to. Doesn't really matter to me. Oh, I forgot to change my LCD to blue. Okay, so now I multiply everything by that LCD. X plus 4, x minus 4. X plus 4, x minus 4. And x plus 4, x minus 4. So even the 5, it gets multiplied by the LCD, okay? So that's sometimes the sticky point where students are like, well, I don't know what to do. Nothing's going to cancel because the denominator is 1. It still gets multiplied by the LCD. Okay, now we're going to do some canceling to get rid of the denominators. X plus 5 is out. X plus 4 out. X minus 4 out. And then nothing's out on the left. You can cross out the 1, but that's just going to be there. Okay, now this is going to be fun. X times x minus 4 equals 32. Okay, so you're looking for what's left, what didn't get crossed out. X times x minus 4 equals 32 plus, and then I'm going to have 5 times x plus 4 x minus 4. The good news is the denominators are gone. The bad news is you got to do some work. Okay, so we can distribute on the left. We're going to get x squared minus 4x. The 32 is there. Now you might remember what I mentioned in some other videos, but when you have a monomial in the front and then you've got 2 binomials, I would multiply the binomials first. So what's x plus 4 times x minus 4? Well, if you remember, that came from the original problem when we had x squared minus 16. But you could also go over to the side and FOIL it out. So if you're like, I don't know, how I got x squared minus 16, you could go over here and do FOIL. X squared plus 4x minus 4x minus 16, and then those are going to drop out because it's the difference of squares. Okay, so hopefully that will work for you. And so I have a little more multiplying to do. So I'm distributing the 5 now. What is that, 80? Yeah, it's 80. Okay, so a little bit more going on in this problem. You might notice that this is a quadratic equation. It's quadratic because you've got the x squared. That means we need to have one of the sides, either the left or the right, set to 0. So I'm going to take everything from the left and move it over to the right. So I'm going to subtract the x squared from both sides. Now see how I'm lining up the x squared terms because those are going to be like terms that are combined. You don't have to do that. You could write it all out in one line, but it's easier if you line them up. Now I'm going to add 4x to both sides. There's no x term over on the right, so I'm just going to throw it in off to the side. All right. Now what do I have? I have 0 here because those canceled out, those canceled out. I have the 32, I'll deal with that in a minute, plus 4x squared minus the 80 plus 4x. Okay. It's a quadratic equation. Hopefully nice things will happen. All right, so I'm going to do a couple things. I want to put it in standard form. So the 4x squared, I'm going to write that first, then the 4x. And then I need to know what 32 minus 80 is. It's negative, I'll say 48. I'm pretty sure it's 48. Yeah, okay. Phew. All right, so we got it to be a trinomial there on the right-hand side. It's quadratic. It's set to 0. We're ready to factor. So this one time there's a GCF. Okay, so I'm going to factor out the GCF, which is 4. And then I have to try to factor the trinomial inside. And it factors into x plus 4 and x minus 3. Okay? So think back to what we learned about solving quadratic equations. That was in chapter 6. I don't remember which section. Probably 6.5. You know, can 4 be 0? No, 4 is a 4. So, you know, the 4 is out of the, that 4 is out of the picture. Now, could x plus 4 equal 0? Yeah, x plus 4 could equal 0. If x equaled negative 4, could x minus 3 equal 0? Yeah, if x were 3. Okay, so I have right now two answers. I have x being negative 4 and x being 3. But now I have to remember way back, what were those extraneous solutions? What couldn't x be? If I'm remembering right, and I probably should look, I'll look. But I think I remember x cannot be 4 and x cannot be negative 4. I'm going to scroll up and just make sure. Where are they? Yep, right here. Those were my extraneous solutions, negative 4 and 4. Okay, so x cannot be the negative 4. The 3 is okay, but not the negative 4. So what's the answer? The answer is 3. If you're doing set notation, it would look like that. So if you have two solutions, sometimes one will work and one doesn't work because it's an extraneous one. Sometimes neither one works. Sometimes they both work. So you have to check them. There's no guarantee that one's going to work and one doesn't. Okay, the answer is 3.